Hello, welcome to Data Talks. Today, I would like to apologize for our technical issues. We are a little bit later, but still we're going to have a great talk today. Is it not as if we're not warned about it? The temperature of the planet is increasing, and this will bring harmful consequences for societies all over the world. Throughout history, humans have built cities according to natural resources and availability of good conditions, such as water and temperature for food production. With the increase of the Earth's temperature, all of this is about to change. Natural phenomena such as the rains in Germany and the dry in Brazil, both of which happened this year, will be more often and less predictable. We might be talking here about human extinction. Since 1992, governments all over the world are developing climate governance in which agreements and goals are settled to avoid drastic increase of the planet's temperature. In the meanwhile, civil society movements such as Fridays for Future claim that national governments are not making enough. Data was always an asset for science, and now governments and citizens need to learn the language of science. How can public data help local and national governments to create strategies to fight climate crisis? And can the civil society herself produce and use this data? Today, we have two very special guests to talk about this with us. From Brazil, we have today Milena Ponczek. Milena is an atmospheric scientist working on the interaction of volatile organic compounds with atmospheric aerosols, air quality, and climate. She holds a degree in chemical engineering from the State University of Campinas in Brazil, a PhD in chemistry at the University of Lyon, France, and she's also a former postdoctoral researcher at the Laboratory of Atmospheric Physics at the University of São Paulo, where her work was focused on better characterizing aerosol life cycles in the Amazon rainforest, and also understanding the impacts of deforestation and biomass burning on the atmosphere. Beyond the context of her technical work, she's interested in social and environmental issues and how create bridges between interaction and so-called hard science and social and economic science in order to make scientific and technological advances approach society. She's one of the producers of the Atmospheric Tales podcast that covers themes related to air pollution and climate change. Milena, thank you very much for being with us today.
Hello, hi Jessica, hi Thomas and everyone. It's a pleasure to be here today with you.
And from Germany, we have today Dr. Thomas Bartoschek. I'm going to say this again, Dr. Thomas Bartoschek. Thomas is a postdoctoral researcher at the Institute of Geoinformatics, University of Münster, and co-founder and CEO of the edtech startup Re-Edu since 2010, and the nonprofit Open Sense Lab since 2021. Thomas holds a PhD in geoinformatics, and he received from IfGI in 2017. His research interests are geotechnologies for spatial learning, human-computer interaction, citizen science, digital education, and data literacy. During his career, he investigated and developed various technologies for citizen science and digital learning, with SenseBox and Open Sense Map being the most prominent. He has experience in leading various research projects on a national level and received several awards for his work. Most relevant is the ACM Eugene Lowe Award for Humanitarian Contributions within Computer Science and Informatics in 2013. Thomas, thank you very much for being with us today.
Thanks a lot, Jessica, for the invitation. Hello, Milena. I'm really happy to be here and looking forward for the talk.
So this is one of those talks that I hope I'm not going to talk too much. I'm going to pose a really simple question first to Milena. So could you explain to us what are the general strategies to fight climate change?
Hello again. So Jessica, you made an excellent introduction to the topic. So I will, moving forward and first giving some, let's say, basic concepts related to fighting and strategy to fight climate change. So we know it's a systematic and global issue that is a challenge that affects all layers of any spheres of our society globally. And of course, such a big challenge doesn't have a simple solution. So currently, some of the strategies and concepts related to tackling climate change, I would say mitigation. And talking about mitigation, I'd like to precisely describe what is mitigation, the definition of the IPCC, which is the theoretical guide for climate change issues. So basically, mitigation is any kind of intervention to reduce the sources or enhance the sinks of greenhouse gases. So it's basically trying to avoid releasing greenhouse gases to the atmosphere. And meanwhile, we have to invest in mitigation policies. We also have to invest in adaptation. That it's a different concept. So adaptation is the process to adjust to the actual climate or to adjust to future effects in climate changes and in temperature rising and all kind of effects that climate change will bring to our society, so cities and natural systems as well. I think another concept that is pretty important nowadays is the concept of resilience, that it's pretty much in the debate right now. So resilience is the capacity of all kind of systems and let's say the social, economic, and environmental systems to handle with hazardous and extreme events. So responding well to those extreme events that climate change is putting us to face, and maintaining, so constructing a way of tackling and to support and to handle of all these extreme events of climate change. So moving forward in some strategies to put them into practice, it's very important to know from where the greenhouse emissions are coming from. We can't think about how to solve a problem if you don't measure, if we don't quantify and monitor sources and sinks of greenhouse gases. So it's extremely important that all sectors and activities that emit, that release greenhouse gases, they monitor, they quantify, they invest in measuring, in doing what we call like emission inventories, to know exactly what kind of process, what kind of activities are emitting mostly of greenhouse gases and other kind of pollutants as well. Because of course, climate change is pretty related to the greenhouse gas emissions. But if you think in a more holistic approach, we can also tackle other environmental issues, such air pollution or water pollution, or also the loss in biodiversity. So all kind of issues are related and have also common solutions, common problems and common solutions. What else?
Yeah, I was thinking when it's quite interesting that I never heard about, I'm not from the field, okay, so I'm putting myself in this debate as a normal citizen who reads the newspaper, the Brazilian ones, not so long ago, and the words mitigation, adaptation, and resilience, they are quite new for me. I heard them recently during the COP26 discussions. And I think when you talk about the holistic approach, we're talking also about, for example, the decision of reducing the emission of methane instead of only CO2, because the methane would also be harmful, but it's easier to recover its impacts once it's not released anymore. Am I saying this right, or am I saying something wrong?
Yeah, so methane is one of the greenhouse gases. What is different? What is the main difference between CO2, carbon dioxide, and methane? So methane is what we call short-lived species. So it's a gas that has a much shorter lifetime in the atmosphere, because CO2 has a very long lifetime, so around 100 years, and methane is has a much shorter lifetime. In this way, since we decrease the emissions of methane, the impacts and the effects of reducing these emissions are also felt. So the impacts are much more. So it's felt more easily and more. It's faster to have the impact, the positive impacts of reducing its emission. Another interesting information is that CO2 is the main greenhouse gas, because it's the most abundant one, and also because of this very long lifetime. But there are many other greenhouse gases, such as methane, that was in the discussion of COP26. There is also nitrous oxides and also the CFCs that are a known problem, because they are also ozone depletion species that are at the same time also greenhouse gases.
Thank you for this explanation. I think we're going to come back to it, I feel, a bit later. But I would like also to invite Thomas to this round and ask him about your experience with SenseBox and Open Sense Map. You produce data from civil society, also to help inform civil society and maybe other actors. So I would like to learn about what you are doing, and if you explain this more to our audience.
Yes, I'm glad to do that, Jessica. Thanks a lot. So first of all, I'm really happy that Milena is with us as an expert, and I really couldn't put it in words, as I'm also not from the field. I'm from Geoinformatics, so usually I start there where the data comes in, yeah. And I'm not from atmospheric sciences or climatology in general, so I'm really happy. Thanks, Milena, for this great introduction here. And Jessica, as you said, we have a project here at the University of Münster. We started, and in our startup now, the SenseBox, as you mentioned, which is a device we have designed and developed here in our Institute for Geoinformatics. And the first ideas started already 10 years ago, more or less, where we worked with high school students in small projects basically to teach them to code and to work with sensors and with environmental data. This was the first aims here, and we started to do that with different approaches and came across possibilities really to let them work with a microcontroller, a small device, connect sensors, and let them code this microcontroller to learn to program, basically. And then they tested their devices, went out of the building and measured data. And the first thing they like to measure was temperature data, yes, air temperature, air humidity. So already some ideas of phenomena that are of course closely related to climate change. And by doing that, we found out that it's pretty motivational to put have this hands-on activity, building a device, programming it, and then having some data with me. So we said, okay, when the data is appearing, data is coming in, it would be interesting also to keep the data and to make it available openly. So we started immediately to develop a platform called Open Sense Map, where the data was going to basically from these devices. So at first we had to make these devices able to connect to the internet and send the data to this platform. And this was the idea of some kind of an ecosystem that was born with that time, with a toolkit, a do-it-yourself toolkit, where kids, but also citizens, can build their own measurement device after posing their own question about the environment. They are being able to code, to program this device depending on the question, depending maybe on the intervals, how often they want to measure or what they want to measure in general. And then having the possibility to really publish the data they are gathering and make it openly available for everyone. So it was somewhat the whole scientific process that is necessary here put into a nutshell, basically, from the question to designing a device, collecting the data, or programming the device, collecting the data, and publishing the data, to be able maybe to answer the question. And the questions, maybe to close here, the questions can be very, very broad. Yeah, it can be a general question collecting just continuously temperature data, which now I said we started nearly 10 years ago, so it's a short term in the climate change topic, but still it is possible. We see that the years every year is getting warmer, so we already can see these things already from the data here. So this was basically the starting point for SenseBox and Open Sense Map.
If I may add something, so just a comment. First, congratulate you for the project. It's very interesting. It's very important because taking the lead of the first question Jessica asked me, I forgot to mention a very important strategy for fighting climate change. There is capacity building. It's again another term that is pretty much in the debate, which means basically like training, informing, having people trained to tackle their problems. And one of the first steps for having people to feel and to be into action is to have their information. And once you are acquiring data, acquiring your own information, you approach like people and kids and let's say civil society to the problem. And so I think it's like wonderful, this kind of project.
I might add also that when we were researching about this episode, I need to say that I fall in love with this idea because I'm from the transparency field in public procurements mostly. So we talk about how money is spent, and there is a lot of this is a big difference in the environment of civil hacker in Brazil and Germany, which is in Brazil there is a lot of interest about public procurement, public spending, because we have our problems. And here in Germany, I saw in hackathons, in open knowledge labs and other parts where I have in contact with civil society hackers, sozusagen, that the main focus here is in climate change, in climate crisis, and how to measure, how to avoid, or how to bring something new that maybe the public policy is not being able to develop. So, and the Open Sense Map to put all of this information and all of this data, because data is not only about information, there is a way that we can measure, we can compare, we can cross. So I thought it was sensational. And I have two more questions about the SenseBox that I didn't hear and I would love to hear, is that I saw that you have the boxes all over the world. I'm really curious to know how could you spread so much, because I saw they are in all continents. And this is quite amazing. And if I understood it right, every single person who acquires, or organization or group who acquires the box, he or she can set up what is going to be measured, or all of them now measuring the same things. Could you explain this a little bit better?
Of course, I will. So the SenseBox and Open SenseMap are in fact two things that interact very well with each other, but they can both be seen completely individually. So maybe I will start with the Open SenseMap as one platform, and the name says it already. It's open in terms of the data which is available there is open data, which was our main intention here, but also it's open for the device that connects to the platform and sends data to, and open to all kinds of phenomena. So it's about environmental phenomena, and it may be temperature, but it also may be radioactivity, or it may be maybe pictures of or the number of birds that come in your garden. If you have a sensor, a camera that would measure that, you can, and people do that, yeah, use it on the Open SenseMap. And it's open for the devices. So we started it, and we connected at first our sense boxes to the Open SenseMap, so they communicate with it. But then people, civil hackers, as you mentioned, Jessica, started to recognize the platform and use their own devices and connected them to the platform. So the devices connected are not only sense boxes, are other devices as well. So this is also the case that a lot of the devices registered on Open SenseMap come also from different projects, or just do-it-yourself devices from civil hackers or citizen scientists that just want to contribute. And as Open SenseMap is also open to the kind of phenomena, either sense boxes or other devices can be configured depending on the question you have. So we have with SenseBox, we have some kind of a standard set of sensors saying temperature, humidity, and particular matter, so dust, in the amount of dust in the air basically are being measured by the most, but also light phenomena like light pollution, UV light, UV intensity, and other phenomena are being measured by a lot of people. And there are some, like, I would say, like exotic phenomena as radioactivity. There are a few sensors for radioactivity on the Open SenseMap, and also the ones for the birds. So these were the two examples I already made. It's pretty broad and open, and depending of the question. Also the code of the SenseBox, we measure quite often. So we measure every minute. Every phenomenon is measured every minute. But if anybody wants, for different reasons, measure in a different frequency, saying maybe I have a environmental measurement station remotely somewhere in the forest, and I don't have that much energy, it works with battery or solar power, I can't measure this or that phenomenon every minute, so I measure it every 10 minutes, yeah, or in other cases much more often, and then I use for example averages to display the data. So there are plenty of possibilities. It's very open. And maybe a last remark, the name, you might have heard already of other open data projects with a similar name. So these are our idols, basically. So OpenStreetMap, the whole concept of OpenStreetMap, a world map made by the people for the people, is one of our idols. And maybe another crowdsourcing project like Wikipedia. We see a lot of similarities here. People are creating a huge database for the people.
This is so much is an intersection between so different fields, but with the same spirit, or to mention Germany Geist, from this openness and collective intelligence that I think is so wonderful. I'm going a little bit forward in our conversation. I would like to ask you both, and in your perspective, of course, if open data is into the reform agenda for global environmental governance. So I would like to understand better if Germany and Brazil if Germany and Brazil have a data policy that allows exchange between different institutes and or universities, and what citizens monitor governments, or how are they managing the policies that can impact on climate? I bring this from my experience in public procurement. So we do have a lot of organizations who are monitoring, okay, how the government is expanding, not only in Brazil, but worldwide. I would like to know if it's the same thing with climate policies. Whoever wants to start first.
I don't know, okay. Just to follow the order, I don't know, but okay. So this is not my field of research. So I'm much more a hard scientist, as I like to say. So, but I guess so. I think open data is, at least from the research perspective, is part of our let's say modus operandi. So there is a lot of data, open data available, mostly by regulatory agencies, universities, NGOs, and other kind of public administration bodies. And there is a huge body of research and open data. That's I'm sure. So I can even mention some of projects that I know, that I've already been a consumer of data. For instance, so in Brazil there is INPE, so the National Institute for Spatial Research, that has different platforms. So they have data from satellites. They treat that data, they process, and they transform satellite data in valuable information for citizens. So anyone in any part of the world can enter in their website and in their platforms. For instance, I know there are different ones. So there is one that the name is Terra Brasilis. That is the INPE platform for deforestation. So they have data, they have graphs, deforestation maps, dashboards, data. So you can download, anyone can download that data, can treat, can make analysis, can, I don't know, play. I like to say, like, play with data. So just download them and try to handle, try to process, try to extract useful information. So another institution that also have wonderful work in public data is called MAP Biomas. So it's a annual. So MAP Biomas stands for Brazilian Annual Land Use and Land Cover Mapping Project. So they produce diverse variety of maps for all biomes in Brazil. So they analyze how land use and land cover is changing in Brazilian biomes, which is very important in the Brazilian context, because so this is a particularity of Brazil, that most of greenhouse gases emissions from Brazil comes from land use change. So meaning deforestation and agriculture. So it's very important for Brazilians, institutions, and also from the public government to monitor how land use is changing in Brazil. What else? Oh, well, I can cite also other international initiatives. So satellites are also a very powerful tool for monitoring climate-related data. As far as I know, NASA satellites have open data. They have open portals. Again, anyone in all the world can go in their websites, open the maps, open the data they have there, like very well treated and very easily to handle. It's available for everyone. Myself, in my research, I have used their fire alert data, for instance, to monitor the fire spots in the Amazon. What else? Well, I can stay longer talking about all kind of initiatives that are very they are fantastic. They are very accessible. That have very quality data, very transparent methodology. So they are very well documented. So anyone can go to the website, read the methodology, read how they calculate each of the parameters they are showing to us. Okay, yeah, Thomas, your turn.
Yes, thanks a lot, Milena. Yeah, I can go on and I can tell and congratulate to you, or especially to Brazil's open data policy. You mentioned INPE, and we were working with INPE data already a long time ago. It's really great. It was already at that time, it's great to see how this can work. Brazil has really an outstanding open data policy already for a long time. And I checked right before the episode here, I checked on the websites of the Open Knowledge Foundation. There is the governmental open data index, and Brazil is amongst the top 10 countries all over the world, while Germany around place 30, 25, 30, something like that. So it's really a huge difference how countries can work with that. And in Germany, we then have another issue which makes things a bit more complicated, which is the federal states here that have different regulations about the openness of data. And starting with maps and satellite pictures or aerial photography, which is really very important in the context of climate change projects and science about it. So only a few years ago, at least the state of North Rhine-Westphalia here, where we are situated, opened this data. Like, I think 2017 was the year where the maps and aerial photography was available as open data. And before that, it was very difficult and expensive to work with that data. So this made life much more complicated. But another issue in general here, not only for Germany probably, is data findability. So really, it's sometimes complicated and it takes time, where INPE and Brazil already had the time to prepare and to make a good accessibility to these data sets, and good explanations, as Milena said, how to access this data, how to download, get the data sets, maybe access them via interfaces, programming interfaces immediately. Well, documentation is very important, and this is a major challenge because it's a lot of work to prepare that. So it takes time. From the point where a country or a governmental institution decides to open the data, it's not done yet. You have to put a lot of work with that. And this is one point. And the second point is also, when the data, governmental data, is online, then we go on, because it's presented very differently from different governmental institutions. And not only as it's online and marked as open makes it good and usable data, because you can imagine if you have some PDF documents marked as open data on a website of an institution, well, it's still a lot of work to get it out to do the science with this data if it's in PDF documents. Yeah, so you need it also in a machine readable format, and this again might be some work and some time takes by. And another example for that from Germany, maybe the German Weather Service. Now we are also close to climate topics. The German Weather Service, with a long history as a weather service itself, collecting data for a long time already, they followed a German law, I think in 2019, where they were forced to open the data sets. And so they did that, of course, they need to follow this law. But then the data is available on an FTP server. Yeah, so you have a link, opendata.dwd.de, and then you are coming on an FTP server. So any layperson, I would say, the citizens, they just need to click through some kind of folders with cryptic names. It's not really understandable. And I know from geoinformatics, it would be really easy to make this data available as a map, to offer diagrams, to offer visualizations of the data also immediately with it. It wouldn't be a problem. But well, they only follow the law, the things they must do, but not the thing that would make life easier and understandable for the citizens. And this is a pity, I would like to say.
I have a question for you, but before Thomas, but before that, I was reading the new Datennutzungsgesetz that was published now in 2021, July 2021, that imposes that research data should be also open by default. So and then my question, I thought at the same time about the Umweltbundesamt. I entered in the website. I was quite surprised with the proposal of this agency, which is to measure is like a interactive from many fields, as I can understand, many different fields. To say Umweltbundesamt means in English environmental office, federal office. So I was quite impressed by that. But at the same time, when I entered the website, I saw a lot of PDFs and I thought, okay, maybe I'm not using this right, because I also didn't know what to look at, to be honest. So I was just randomly seeing to see how they were making the data offered, and I was quite like, okay, there's a lot of information, but it's not data. So I mean, someone who can use it, of course, it is a good place to have everything in the same place. But I was quite confused. So I was going to ask you if you use a lot of it, if I look at the wrong place, or what do you think about this strategy? I mean, this was we didn't talk about this earlier, but I'm curious now that we're talking about it.
Yeah, it depends. I'm not exactly sure which kind of, because the Umweltbundesamt, the German environmental agency, I would call it, has of course a lot of data sets and a lot of topics they care about. So really very broad topics. So I'm not sure where, but I'm pretty sure that you found a lot of PDFs, because this is how it starts. So I believe, as you said, plenty of these laws in Germany are new. And I mentioned open data for Weather Service 2019, in North Rhine-Westphalia for the maps and area photography 2017. So we are speaking of a few years, and it starts with these steps. And it's Germany is on the way, late and a bit slower maybe. So I believe it's a start. And I can go back even some years and make a small example from Münster, from the city of Münster, where we started an open data initiative within the city, coming from science, from university. So we got in touch with the city government and the people from the it's some kind of an office for green spaces in the city, and we asked them to open the data, and they were, oh no, maybe the city can make some money and sometime with that we can't open. Okay, we will do it. So what they did is they just put 2 Excel files on their website about the places of playgrounds and sports places in the city, or something like that, which was not very valuable but it was a first step. And this was, I think, more or less 10 years ago. And now, already since 2 years, the city of Münster has an officer, an open data officer. Yeah, so a person with a full position, only working for the city to make data from the city openly available and accessible and findable. So it was a way from the first data sets to now having a person, having an open data portal for the city, a long way, 10 years. Yeah. So maybe the Umweltbundesamt is on this way, but not yet there.
Yeah, no, of course, it's much more difficult to make this work all together. But I'm really glad that you mentioned the city of Münster. I participated in the hackathon, and they allow us they sent to us a lot of databases, and I was impressed of how much environmental databases are found there. And I think 2 things we can say about what we said so far is that maybe governments have to learn from examples like INPE or other agencies that Milena mentioned of how we can actually make data available. And also that we are going in some direction. We're mixing these two worlds of citizens and or better saying a broader access of this data for citizens that are not experts. And now I would like to come back to something that Milena said about capacity building. Because we talk a lot about INPE. She mentioned satellite. Sorry, she mentioned satellite data, and I actually work already with Sentinel. I mean, I did a workshop. It was quite fun. I learned a lot. I coded and I saw the images. And they said, oh, you can make a little project of that, like just to use the code, just to practice. And I said, okay, what can I do with that? I have no idea. I'm a political scientist. And then I made a map of Brumadinho, the area of Brumadinho, which has a natural, I'm sorry, it was not a natural disaster. It was an environmental disaster caused by a mining company some years ago. So I took the satellite images from before and after to see the spread of the mud that came from this disaster. But then I was thinking now, when I was listening to you both, that how can we actually make local citizens who are sometimes not PhD students in atmospheric or PhD students in Geoinformatics, and how can we make them work with data once this data is available, once there is this opportunity? How would you share this experience about creating capacity building?
So, okay, for sure, like training and having people trained to have programming skills. It's a very important part of the open data policy, because for sure, as you mentioned, so it's not that easy. So for lay people to just jump into a website of, let's say, NASA or even INPE and download a database, it's not that intuitive. So you need some background before starting dealing with this data. And I would say that satellite data it's a key data, because they are very powerful. Again, you can, like, satellites can measure almost all kind of environmental parameters we can imagine, but they are not easy. They're not ready understandable for lay people. I think it stays much more in the research field community than for like a regular public. But one thing that I was thinking about, so during the discussion, it's that sometimes, so the raw data, let's say, or even if it's not raw, but data in a data set, it's hard to understand for lay people and for people that doesn't have a programming background. I'm a pretty fan of reports. So I think reports are a very useful framework that gives transparency to organizations and to public sector. Sometimes we can't, that's the thing. I can understand like atmospheric data, atmospheric information, but I can understand, let's say, procurement information. So for me, as a lay person in this field, I love to read reports. So I think it's important to the public administration to produce nice, beautiful, readable, and complete reports from these parameters that are being measured and needs to approach civil society. So what is your opinion about that?
I can maybe add to the question, to Jessica's question, and add on top of the reports, and going a step back also, you mentioned programming skills, which I find really interesting and impressive and really important to have for that. But we can go even one step further. And as I mentioned in the beginning, I started this journey here also in the educational sector, so in schools, even not even higher education, but in secondary, sometimes even primary education. And there, maybe even before programming skills, the general data skills, or how we call it, data literacy, is something we need to focus on much more already in school times amongst the youngest. Of course, we all would need it, and we know now that there are jobs like data scientists and whatever, so there will be people, more people working in that, but we need to start early to teach data literacy and to have it as a basic skill amongst the general skills of reading, writing, and so on. And we do that with the Sensebox on the one side. We do that also in other projects. Recently, we had a project called Klimadatenschule. We are still working on that, where it's the climate data school, basically, where schools participate and they the high school students, 12-year-olds more or less, learn to collect data in different fields that are related to climate change. And it doesn't have to be direct climate data like temperature data or whatever, but this indirect data, maybe much closer to what Milena said before, data that helps us to understand how to release less greenhouse gases, to change the acting of the people. So it might be data about the food in the canteens of the schools. This data, there is no data about that, but the high school students might start to collect this data, open this data, and work with that data. And working with data means then, if they collected this data, they need to be able to access it, to download it, and then maybe start really with the simple things in a spreadsheet, Excel, or whatever kind of system, just to work with basic statistical things that are possible in that time, in the ages, and then go on, and then maybe come to the next step, which would be the programming skills. If you have a lot of data, you would even need more maybe scripting skills, and use some tools like Python or whatever to dig into the data and find things that are not visible on the first look, basically. And this is interesting, and especially this extra data, this indirect data related to climate change, is something where there is a lot of potential concerning to data literacy.
I made this question because I was thinking more about how can we make local interventions since we have the data, because that is a problem. Governments, they do have a lot of power, they do have a lot of money, they do have a lot of agency, but they, as we say in the political science field, they are like elephants. They move really slowly because they are heavy, and we cannot expect everything to be done by governments. And I'm thinking about local interventions that could be made using this data. So that was also a little bit the spirit of this question. It was a bit, can we use data somehow, if I'm not a specialist, in a way that I can make local interventions? Maybe what Thomas mentioned, to emit less greenhouse gases would be a way, or to make maybe a building more efficient. I don't know, I'm kind of thinking out loud here, brainstorming here, but I do think that I don't want to remove the responsibility of governments, because we do know that most of the polluted gases and most of the problem do have to do with strategic national policies, but also we could increase or improve. Sorry, we could improve our local environment. And I think small interventions that allows birds to come back, or trees to grow, or I don't know if I'm being naive by saying that, but I have this this faith that most of the change has to do also in local based change. But anyway, keep going.
But of course, like climate change is such a complex issue that all kind of levels must be involved, right? There is this strategic and diplomatic sphere that like policymakers and big strategies and big policies, global policies, national policies must exist. But also, I also believe that we as citizens and as regular people also have some kind of power, or even if we as individuals, as a community, as a group of people that wants to like do something, right? And I think one of again, another concept, another interest term is that it's what Thomas actually is, the work of Thomas is part of, we call like citizen sciences, that it's like putting people, citizens, to produce science, to produce data. And it doesn't have to be, again, as Thomas also have said, it doesn't have to be very fancy kind of data or very fancy sensors. Sometimes people can just monitor, like for instance, the level of water in a reservoir. It doesn't require any kind of sensor. It's just go there and check. Or another example that I can think about, like monitor the color of the sky. Like how is my impression of the sky today? Like day one, the sky was pretty blue or was pretty cloudy, or I see some pollution or some particles in the air. There are a variety of sensitive information that people can start being familiar with. And that approach to the idea of monitoring, of having a data management, I don't know, the others as well. Like you can put people to, if you have a community, for instance, that live close to a factory or to a big power plant or whatever, they can simply monitor the odor of the air. It's something very simple and makes this kind of proximity between individuals and having the same sense of data science, as we call in a fancy way, right?
Jessica, may I jump in and go on? Yes, so with the local intervention, so these are great examples for citizen science projects, and we see the SenseBox and Open SenseMap as a citizen science project and initiative. And maybe, as you said, this need for this local interventions in cities, I see the same, and I believe that the citizens want the change. They want a complete change, the majority of the people at least. And as you said, the cities, the governments are pretty slow and heavy ships, yeah, to move. And sometimes they don't want to react immediately if some citizens come around. So I like a quote I found here and there on Twitter and so on. People without data have an opinion. And that's how cities may take the citizens saying, you have to change this and that because of that. This is an opinion, yeah. But people with data have evidence. So if people are facilitated to collect the data and even to prove that it's good data, then they have evidence and can even foster this change of a city government. And I would like to make a very recent example of a project we do right now with SenseBox in Berlin, of such kind of intervention. So when we think of reducing CO2 emissions, one good thing to do is changing from cars to bikes, basically. And this is, and we can agree, I think, on that this would be a really great intervention all over the world, yeah, to do so if it's possible. And but we know about large cities having usually, not all, but usually not good conditions for biking in a lot of terms, air quality, cars, dangers, and so on and so on. So what we are doing right now in Berlin, a group of citizens, 30 citizens, are equipped with mobile sense boxes. They're attached to their bikes. They build them themselves in a workshop with us. And they are collecting environmental data while riding, so on air quality, for example, temperature as well, but also data that on the first look is not related to climate change. On the second, it is. So they are collecting data about the distance to the cars, how close are the cars coming, and about the how bumpy the road is, about the quality of the road, basically. And they collect this data while riding since a few weeks, and this data is being collected and available as open data on Open Sense Map. And then this group of people can take this data and bring it to the local government. And we had in the workshop a person from a district of Berlin that said she is the person responsible for bike lanes. Yeah. And I can't decide which bike lane to do first, so I need data, but the city of Berlin do not have the capabilities to collect this data. So now these two words meet. Someone of the city being slow because there is no data meets the civic enthusiasts, biking enthusiasts, they are collecting data. And now we hope that this can change things in the city.
I'm really, I didn't know about this project. I really want to know about this more. Eric Kill also, he mentioned a comment that I'm going to bring it here. Hi at IFUSP, I think is the Faculdade de Medicina, if I'm not wrong, please correct me. We have developed low-cost equipment that we have calibrated and we are using it to monitor cyclists. Congratulations on SenseBox initiative, Thomas. So this is a fan.
Yes, I know Eric. Thanks a lot, Eric. Greetings, Brazil. I know about his initiative. We are more or less in touch. I have to respond on to a message. So hi to Eric.
And I have a last question. Our time is going, and Axel, I'm actually pushing a little bit further. I hope you don't get upset with me by doing that. But we have a last question. So we have both goals for 2030 and 2050. 2030 and 2050. So regarding this, I would like to get your perspective. Is there any data that we are not collecting and we should collect?
So maybe just to change the order, I hope it's okay, Milena. So I think the last example I made with the bikes is a start. Yeah. So this data, there is no data like that around. So we need to do that. And there are no aims to collect this kind of data from the governmental side, as far as I know. So this is one example of this somewhat indirect linked data to climate change. So I think this is one example. There might be more on data on trees, for example, knowing where really how many trees are around, because we always speak about some kind of mass, and this is the other way around where CO2 can get capsulated. Basically, I recently read a paper of a colleague of mine that used AI methods to count trees in the Sahara, yeah, and they had an impressive number of, I don't remember, 2 billion trees in the Sahara, where one would think there are no trees, and it's based on satellite data, of course, and image recognition and so on. And this was new to me, completely new, that there are so many trees in the Sahara, and also this data is then new, and we need more of this kind of data that is indirectly related from topics like biking or trees, and there are for sure more. When I spoke about canteens, yeah, food, and here we come again back to Brazil. Maybe Milena, you can maybe continue in that direction. When we think about food production, land use, that has a strong impact on climate change then again. And here we think about deforestation that is being done in Brazil due to which food is needed and how the food consumption also in Europe then works. Yeah? If we would maybe eat less meat, this would have a strong impact on climate change. Yeah? And this is one example where a lot of data indirectly is involved in this question. should be.
Yes, for sure. We can cover even more data related to climate change, direct and indirectly speaking. One thing that comes to mind, like just came to my mind, it's the need of like more regulation. So, for instance, by now in Brazil, companies are not. It's not mandatory for companies to make greenhouse gases inventories. For instance, it's still voluntary. So companies are starting to doing that because of international pressure, because of this whole international discussion about greenhouse gas emissions, but it's not mandatory. So maybe having more regulations, public regulations and law about greenhouse gas emissions would increase awareness, would increase the collect of data, would increase the management of these emissions in the federal perspective. And this is not just for greenhouse gas emissions, also for atmospheric emissions. In Brazil, for instance, this is what I work with, like an air quality. We have very few monitoring. Not all states agencies have the capacity of measuring air quality parameters. For instance, I know that in the state of São Paulo, the CETESB, that is the environmental agency of the state of São Paulo, they have a very good infrastructure for measuring all kinds of air pollutants. The data is available, it's open, they have very good reports, but it's not the reality for all states in Brazil. And for instance, in Amazonas, in the Amazonian states, they probably don't have this degree of control in air pollutants, and it's a region that it's in the core of the discussion. So they need to improve their infrastructure, their capacity to measure and to monitor air quality. That it's a way of knowing if biomass burning is occurring, if deforestation is happening all around them. But just to mention some examples.
Well, our time is up and our extra time is up. So I would like to thank you, Milena Ponczek and Tomasz Bartoschek, for being with us today. And okay.
Yes, it was a pleasure. Thanks a lot for the invitation, and thanks, Milena, for the great talk and the insights into your work.
And thank you, you too, Jessica and Thomas. It was very insightful. I learned a lot. It's wonderful to have people from different backgrounds discussing a common subject. I appreciate a lot.
And finally, I would to thank you who is watching us today for taking your time to be part of this discussion. Data Talks is a series of talks between experts from Brazil and Germany who discusses the use of public data in today's society. The Data Talks is an initiative from myself, Jessica Vogt, as part of the German Chancellor Fellowship from the Alexander von Humboldt Foundation, and is hosted and supported by the Brazil Center of the University of Münster in the framework of the Strategic Partnership Project IFUSP, funded by the DAAD. I will see you in the next talk. Have a nice weekend.